Algebra 2, Lesson 5-2, Properties of Exponents and Radicals. In this lesson, we'll be able to use properties of exponents and radicals to simplify radical expressions. The vocabulary that we will look at would be like radicals and reduced radical form. Let's start with looking at critique and explain. Olivia was practicing evaluating and simplifying expressions. Her work for 3 expressions is shown. So you can see that the first equation, she has 24 squared, would be equal to 400 plus 16 is equal to 416. Is that correct? And then the second one, 3 to the power of 6 power could be rewritten as 9 times 27 is equal to 270 minus 27. So that would be 243. Is that correct? And then let's look at the last question. Square root 625 should equal to root 400 plus 225, and that's equal to 20 plus 15, and that's equal to 35. Is that correct? So let's look at the first example. Is this correct or not? Can we do this? How might she have gotten this? So 400 is probably 20, she probably thought of 20 square, right? So then she has 20 square and then 4 squared. So she separated 20 and 4 and got 20 squared plus 4 squared. Is that correct? Well, they're not equal to each other. Why? Why? So first of all, if you actually multiply 24 times 24 and get 24 squared, you'll see that 4 times 4 is 16, 2 times 4 is 8, and then that's 48. And then you have 6, 7, 576. That is not equal to each other. They're not equal to each other. So what is wrong in this logic? She just assumed that because 24 is 20 plus 4, she can separate it like this, but the logic is false because it's 20 plus 4, all of that squared. And she thinks she can square each of the terms here. But no, you have to add first and then square because you need to solve parentheses first. Remember that? So you can't really distribute the power in this case. Only when you have a multiplication, if you have 20 times 4 and then you have square, then you can distribute it and say 20 square times 4 square is the same as this. But we don't have that, right? So if you have addition, you need to be careful. You can't, this is not equal to each other, okay? So no, it does not. So we can say no. 24 square is 576, not 416. 24 squared is not 20 squared plus 4 squared. So you can't do this. What about the second example? 3 to the 6th power. Why did she write 9 times 27? So I think she separated 3 square times 3 cube, right? Because she thought she could multiply the powers, but what does the power product property says? If you have the same base, you add the powers, not multiply them. Powers property says you can multiply the powers when it's when there's a power on top of a power. Okay, but this is the same base multiplied each other with different powers. So in this case, they're not equal to each other. 3 square times 3 cube is equal to 3 to the 5th power, not 6th power. So no, this one is not correct either. 9 could be written as 3 square. 27 could be written as 3 cube. So 3 square times 3 cube is equal to 3 to the 5th power, which is 243. And that's not equal to 3/6, which is 729. What about the third one? What's wrong with the third one? Well, again, she thought 400 plus 225 is equal to 625. So, oh, I can just separate them, right? No. Well, you can do 400 plus 225, but that's still 625, right? Yeah. But that square root is after you add them. So this one is first. It has to be 625 and then squared. You can't like change the order of operation. So this is like changing the order of operation, and that's not true. And this is not equal to each other. Not equal to each other. So radicands cannot be added in this way. Root 625 is just 25, right? So 25 squared is equal to 625. So root 625 is just 25, not 35. So no. Root 625 is 25, not 35. She cannot separate, she cannot switch, let's say. She cannot switch the order of operations. Okay, so what advice would you give Olivia on simplifying expressions? She seems like she's struggling a lot. So what would you say? What would you tell her to help her? You could tell her to what? Follow the mathematical rules and properties that she knows, and always check her answers to make sure they work. So we would tell her to follow the mathematical rules and the properties and always check her answers, because it doesn't take long to even check your answer. You can literally multiply 24 times 24 and get 576, and that's not equal to the answer. So checking answer is very important, and make sure they work, to see their work, right? Yeah, so the essential question for this lesson would be, how can properties of exponents and radicals be used to rewrite radical expressions? So it's really important to know all the properties, right? So we did go over this. We did learn the properties of exponents in Algebra 1. But let's review that concept, properties of rational exponents. So remember, we have these properties. We have product of powers, where you have the same base but different powers. You can add the powers and combine the bases together because they're the same anyway. Quotient of powers says that if you have the same base with different powers but as a quotient, then you can subtract the powers. So it works in a similar way with the as product of powers. It's the opposite operation. And then power of power says if you have the same, well, it's just one base, okay? If you have a base with a power of a power, then you can multiply the power. So remember, a lot of people confuse the product of powers and power of powers. So if you have one base with power on top of power, then you can multiply. If you have the same base, but you're multiplying them separately with different powers, then you add the powers. They're on the same level, right? The powers. But if it's power on power, then you have to multiply the powers. Okay, that's very different. And then power of product, you will, if you have different powers with different bases with the same power. Power product property says that you can multiply the bases and combine them. So for example, if you have, let's say, 7 square times 3 squared, that's the same as 7 times 3, which is 21 squared, okay? A negative exponent property says that if you have a negative exponent, that doesn't give you any negatives in your value. It just means divide, because positive exponents mean you're multiplying your base by that many times. So the opposite of that concept would be division, right? So you're dividing your base by that n many times, right? So 1 over a to the n power would be a way to write it as a positive exponent. So when you simplify, write it as a positive exponent, okay? Then there's one more thing that we didn't talk about, but you should already know, would be the 0 power property. That would be when any number to the 0th power would equal to 1, right? So there's that. So please remember the properties of rational exponents. If you don't know this on top of your head, you should write it down in your notes and refer to that as you go through this lesson, okay? Let's look at example 1. Use properties of exponents. How can you rewrite each expression using the properties of exponents? So this is an example. You have the same base, right? 81, 81. Then using the product of powers property, you can add the powers and keep the base the same, 81. And then 5 over 6 plus minus negative 1 over 3. And then you have 1 over 2. And then you can simplify by using a different base. 81 is basically 9 squared. And then 9 squared, well, technically you could have 3 to the 4th power, but why are we using the base 9? Because we have a rational power where the denominator is equal to 2. So we want to match that power so that we can easily simplify and save some steps. So 9 squared to the power of 1 over 2 will cancel each other out using the power of power property, right? And then you just have 9 to the 1st power, which is just 9. So use the property. Part B, let's simplify this equation, this expression. We're going to have power of powers property. So in this case, you have to distribute the powers. If you want to distribute the powers first instead of using the quotient of powers property. So then another way would be distributing the power x to the power of 2 over 3, y cubed to the power of 2 over 3 over x to the power of 1 over 2 to the power of 2 over 3. So this power has to apply to all the powers inside the parentheses. As long as you only have multiplication, that works. Yeah, remember in Olivia's example, you cannot do this when you have addition or subtraction in your parentheses. Then you have to do that first. Okay, this one, it's already simplified and you don't need to add or subtract anything. So you can distribute the powers. But anyway, let's look at the quotient of powers property first. Because we have x to the power of 1 over 2 in the denominator, you can use the quotient of powers property to combine your powers of x. And you have 1, if there's no power, it's just automatically power of 1, right? So 1 minus 1 over 2 would be the new power, which is just 1 over 2. And then you have y cubed. So this one, then you can distribute the powers and say, oh, 1 over 2 times 2 over 3 is 1 over 3. And then y to the cube times 2 third would just be 2. And then you'd be able to simplify and write it in radical form. Yeah. So why can we distribute the powers? So think of the power of product property and then the power of power property as well. So do it step by step using the properties of exponents. Let's look at try number 1. How can you rewrite each expression using the properties of exponents? So rewrite them, simplify as much as you can. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at number 1a. So you have 3 over 32 to the power of 2 over 5 to the power of 1 over 2. So this one, you can rewrite 32 as a base 2, right? So you have 3 over base 2 to the power of 5. 2/5 is 32 to the power of 2 over 5 to the power of 1 over 2. And then now that we matched our power with the denominator here, then we can cancel this out using the power of power property. We have 3 over 2 squared, right, which is 4 to the power of 1 over 2. And so this is equal to root 3 over root 2 squared, which is just 2. So root 3 over 2 would be our final answer. And then let's look at part B. So that was part A. Let me write it on top here. So part B, we have 2a to the power of 1 over 3 times ab to the power of 1 over 2 to the power of 2 over 3. And so again, solve it one by one. I would solve the parentheses first because order of operations. 2a 1 over 3, and you can distribute the powers, use the power of powers property. A to the power of 2 over 3 times b to the power of 1 over 2 times 2 over 3. And then this one, you can cancel it out to 1 over 3. And then using the product of powers property, you have 2 times a to the power of 1 over 3 plus 2 over 3 times b to the power of 1 over 3. And then you just have to do the math. You have 3 over 3, which is just 1. And then b to the power of 1 over 3. And then you can write it as a radical expression and have 2a and then cube root of b. Okay, good. So we have rewritten our expressions using properties of exponents and simplified them. In example 1. Let's look at example 2. Use properties of exponents to rewrite radicals. So how can you extend the properties of exponents to derive the properties of radicals? So let's look at this example 2a. How can you rewrite nth root of ab using the properties of exponents? So we want to be able to rewrite this into different form. One form is to be able to write it as rational power, but first of all, we can use rational exponent to write it as power of 1 over n. And then we can distribute that power using power product property. And then you can rewrite as radicals. So this is just one thing you can do. If it's multiplication, you can separate like that. If there is addition, you cannot do this. Think of Olivia's example. Okay, so if there's addition or subtraction going on, you need to be more careful about the order of operation. But here, this works. And then in the same way, if you have a over b, you can also write it as nth power of a, nth root of a over nth root of b as well. What about specific expressions like this? Cube root of 16 times x to the power of 5. How can you rewrite this using properties of exponents? So you can rewrite. So you can factor as much as possible. So 16x to the 5th power, you have to factor out the constants. So divide by 2, divide by 2, divide by 2, and then you can write it as 2 to the power 4. And then, or you can expand that. So 2 times 2 times 2 times 2 times x times x times x times x times x, right? But cube root says if you have a power of 3, then it's the same as power of 1, right? So you can rewrite this as 2 cubed and then 2 times 2. Now you can rewrite this as x cubed times x squared, right? Then you have a cube root. So cube root applies to all of this. So 2 cubed to the power of 1 cube root would just give you power of 1. So that's gone. And then this one is remaining. And that one is also out. So you have 2x and then cube root of 2x squared. And that's why we can rewrite this as 2x times cube root of 2x squared. And that's how you simplify things. So writing the expression, this may be referred to as a reduced radical form. You're simplifying it and reducing it as much as you can, but writing as a radical form as well. So all the rational powers, if you have any, you're going to, so like these rational powers, you're going to reduce it and make it into a radical form. Yeah. Let's look at try number 2. How can you rewrite each expression? So write it as a reduced radical form for each question A and B. Pause the video, come back when you're ready for answers. Okay, are you ready? Let's look at part A. So try number 2A. So 81, you need to factor 81 out, right? Divide as much as possible. 81 is divisible by 3. 27, 3 divisible again, and then 3 times 3. And so that is 3 to the 4th power, right? So you have 4th root of 3 to the 4th power, and we know that's going to make a power of 1. And then a to the power of 4 times a to the power of 4, right? You can separate that. And b to the power of 4 times b. So rewrite this so that we can have a power of 4. And then these are out, right? Because this will cancel all the powers out. So then you have 3 times a times b times 4th root of b. And so writing as a reduced radical form, you will finally have 2a squared b, 4th root of b. Okay, and then let's look at 2b. We have cube root of x 4th power y squared and then 125x. And so here you would do the same. This x to the 4th power could be rewritten as x cubed times x. So you have x to the 1st power outside your radical. And then you have x in there. And then y squared is just y squared, right? And then you have 5 to the power of 3. And then you have x. And then you can still simplify. X divided by x is 1. And then 5 to the power of 3 will have a power of 1 over 3. So powers property says you have 5 to the power of 1. So you have 5. This is 1 over 5 though, right? So you have x over 5 times cube root of y squared would be the reduced radical form. Or you can write it as x cube root of y squared all over 5. Okay, let's look at example 3. Let's look at this concept first. So properties of radicals. The product property of radicals says that the nth root of product is equal to the product of nth roots of the factors. So this is equal to that. And you can write it as a rational exponents like this. Quotient property of radicals says it's the same thing, but if you have a over b to the nth root, then you can rewrite it and separate your roots and say nth root of a over nth root of b is the same as nth root of a over b. And then you can rewrite it as the exponential form like this. The rational exponent form like this. Let's look at example 3. Rewrite the product or quotient of a radical. So for example, what is 5th root of 16 times 5th root of 8 in reduced radical form? So using the properties, we're going to simplify and reduce and write it as a radical form. So since we have the same root, it's like having the same power, right? Because that's basically 16 to the power of 1 over 5, 8 to the power of 1 over 5. So we have a property called product property of radicals, and we can combine the numbers inside the radicals, and then we can multiply them, and we can factor it out and see if we can find any powers of 5, right? So it's easy if you understand factoring first. So factor 16 out, right? And then you'll see that it's going to be 2 to the power of 4. So really you have 5th power of 2 to the power of 5. Wait, no. 2 to the power of 4 times 2 to the power of 3, because 8 is 2 to the power of 3, right? And so then we are basically adding the powers and saying, oh, that's really 5th root of 2 to the power of 4 plus 3, 7. And so because we have 2 to the power of 5, we can rewrite this as 2 to the power of 5 times 2 to the power of 2. And then we can cancel the 2 to the power 2/5 with the 5th root, and then say, oh, then that's really equal to 2 to the 5th power to the power of 1 over 5, which is just 1, times 2 squared to the power of 1 over 5, which is 2 over 5, which is just 5th root of 2 squared, which is 4. So the reduced radical form would just be 2 times 5th root of 4. Okay, what about this example? What if you have different roots? So 6th root of 8x times 3rd root cube root of 2x, right? You can rewrite using rational exponents like I did, and then write it as 8x to the power of 1 over 6, 2x to the power of 1/3, and then you can see that you can see that you can rewrite 1 over 3 as 2 over 6. And why are we doing this? Just wait and see. So then we have 1 over 6 and 2 over 6. Then now, if it seems like you can use this as a separate square, right? So 2x to the power of 2 over 6 could be rewritten as 2x squared to the power of 1 over 6 using the power of powers property, right? So you can go the other way as well. And then now we have the same power. You can use product property and then multiply 8x and 2x squared. Yeah, so this one. And then you will be able to simplify into the radical form. Let's look at another example. What about cube root of 2n over 9m? Well, just like we looked at, we're going to use quotient property of radicals and say 2n to the power of 1 over 3 over 9m to the power of 1 over 3 would be the same as that. And then you're going to rationalize the denominator. You're going to multiply by the same root, right, with something that will rationalize, like you want to get rid of that root, right? So in order to do that, right now, why are we multiplying 3m squared, not just the opposite, like 9m? Because yes, you can multiply cube root of 9m over cube root of 9m, but that's gonna give you more steps because you have to simplify more later. Well, if you think about it, 9 is 3 squared, right? In order to be able to cancel out that power, you have root 3, right? So then you just need another 3 in order to be able to have a cube. And then you'll be able to cancel the power out, right? So we need another 3 with one more power. So that's why we're multiplying 3m squared, not 9m. Okay, and then because m, you need two more m's, right, to multiply so that we can get a rational number, a real number without a radical, right? An m to the power of 1. So then that's how we got this number. And then you multiply the same number on the numerator so that you're not changing your expression, you're just multiplying by 1. And then you'll see that this is 27m cubed, but that's really 3m because that's 3 to the power of 3. And so that cancels the power. So you have 3, and then the power cube and the cube root cancel each other out. So then you have m. And then you just have whatever is on the numerator that you multiply. So in reduced radical form with the denominator being rationalized, you have this form. So if you see any radical form in the denominator, you have to rationalize the denominator because that's the simplifying process for these expressions. Okay, so let's look at try number 3. What is the reduced radical form for each expression for parts A and B? Pause the video and come back when you're ready for answers. Okay, are you ready? Let's look at part A. So you're going to use the product property of radicals, and then the quotient property of radicals, and then separate this into fifth root of 7 and fifth root of 16x cubed. And then you're going to rationalize the denominator, right? Because we don't want radicals in the denominator. So then you're going to see, how can we change the base for 16? So rewrite this as 2 to the power of 4 and x cubed, right? In order for 4 to be 5, you just need one more. And then in order to 3 to be 5, you just need 2 more powers, right? So then you're going to multiply what? Fifth root of 2x squared. And so you'll do the same thing for numerator. And now you have 2 to the power of 5, x to the power of 5, and then the root is canceled out. So you have 2x in the denominator, and then on top in the numerator, you just multiply them together. You have fifth root of 14x squared. And that's as simple as you can get. So the reduced radical form would be fifth root of 14x squared all over 2x for part A. Let's look at part B, 3b. You have fourth root of 27x squared times square root of 3x. So you can rewrite this as rational form. You have 27x squared, but let's write this as a power of a reduced base as well. So 3 cubed x squared to the power of 1/4. And don't forget to put the parentheses, otherwise you have to multiply 3 to in 1/4 because power of powers property. 2 times 1/4 power of powers property. So 3x to the power of 1/2. But let me show you like step by step so that you, we don't make mistakes by just skipping steps too fast. Okay, so 3 to the power of 3/4 times x to the power of 2/4, which is 1/2, times 3 to the power of 1/2 times x to the power of 1/2. And then let's simplify. We have the same basis, right? So we're going to add them using the property of exponent. 1/2, and then x to the power of 1/2 plus 1/2, that's 1. And so you have, this is 2/4, right? So 2/4 plus 3/4 would be 5/4. So times x to the power of 1. And 5/4 means you have 1 plus 1/4. And that's really 3 times x to the power of 1/4, right? Yeah, the product power property, right? So then, wait, what did I do? 3 to the 1/4. Yeah, product power property. And then you have 3x 4th root of 3 if you write it as a reduced radical form. So that's going to be your final form. Okay, so that was example 3 and try number 3. Let's look at the next page. Example 4. Add and subtract radical expressions. What is the sum of root 20 minus cube root of 16 plus cube root of 250 minus root 5? So this is a vocabulary word. Like radicals have the same index and the same radicand. Index is this little guy in the radical symbol. So the nth root, the n is the index, okay? And the same radicand just means you have the number inside your root, right? So that's the radicand. This is the radicand. Only like radicals can be combined with addition and subtraction. So for example, you have root 20, root 5. These are like radicands because why? They're both constants. And then they're both square roots, right? So if only your index is the same, you can combine the radicals because they're called like radicals. So square root 20, square root 5, you can combine them together like this. And then cube root, you can combine them together. So let's see how to combine them together in detail. So square root of 20 minus square root of 5. If you simplify square root of 20, you'll have 2 root 5. And so root 5 is almost like a variable now, okay? So 2 minus 1 root 5, you'll just subtract 2 and 1, and you'll have 1 root 5. So you need to simplify all your terms, and then you can add and subtract like terms. And in this case, your radicals will act like variables. And if they have the same index, then it's going to be the same like variable, right? So they're like radicals. So then you can add and subtract. So yeah, but you need to reduce it so that you have the same number inside the radical as well. So if you have the same radicand and same index, then they're like radicals, and you can add them like this and combine them. Okay, so for this one, you'll have the expression root 5 plus 3 cube root 2 as the final answer.